Okay, in this example, we're determining the magnetic flux, and we're just looking at the shape. So we're looking at this graph of magnetic flux, and we're determining the induced EMF. And EMF, the induced EMF, is a voltage. So what this means is when I have a changing magnetic field or a changing magnetic flux, which is this what this graph is representing, um, then I will induce a voltage or a current. So usually we've been talking about if we have a changing flux, magnetic flux, will create a current. If we create a current, then we're also creating a voltage. And so we can determine what the voltage is using this formula. So this E is representing the EMF, meaning an induced voltage, not created by a battery, but created by a changing magnetic field. And this formula says our changing flux over changing time. And so this just means that if my B field or my area of the loop changes, then I'm going to have a changing, changes with time. I'm going to have an induced voltage or an induced current. And the negative sign just tells us that if our flux is increasing, then our voltage is going to be in the opposite direction, right? And that makes sense from the problems that we've been doing. We see that we're trying to get back to what we had before. So our induced EMF is trying to offset or cancel this change. So when we look at this graph, right, uh, when we look at this graph, if we have an increasing EMF or think about an increasing magnetic field, then what we're going to do is we're going to create an EMF. So let's say this changing B, changing phi over T is a slope, right? So what we're looking at is we have this line and we want to see the slope. So this slope is positive here. And so we take the negative of the slope. So we should get, because the slope is a constant, right? We have a line. So we're looking at the slope of this line. We know it's a constant positive number. We multiply times a negative and we're going to get a constant negative number. So we're going to get something that looks like that, just a straight line across. And now if you look at this line here, right, we're not changing the flux at all. So the change in flux is a constant. So that means our slope is going to be 0. So we get 0 from here to here. And then here we have our changing flux is decreasing. So that means our slope is going to be negative here. So negative times a negative is going to give me a positive. And the slopes look about the same here. So I'm going to try to make these about the same height, meaning this distance is equal to this distance. All right, what about here? So I have, there's no change in my flux here. It's a constant. My flux is a constant, but it's not changing. So that means my EMF, I'm going to have no induced EMF, no currents created. Here I have a negative slope here. So a negative slope, that means I'm going to have a negative number here times a negative number will give me a positive here. And now I have this line here is a positive slope. And so a positive slope times a negative is going to give me a negative number. And this slope looks steeper than this one. So I'm going to have a bigger negative number. So meaning this, right, is going to be bigger than this because this slope looks steeper than this slope. So on this one, I have a positive slope multiplied by a negative. I'm going to get a negative. I have not a slope that's flux that's constant, so my slope is 0. So I'm going to have 0 here. And when I get here, here I have a flux that's decreasing, right? So I know I'm going to have decreasing. So my slope here is going to be, if I drew the slope, right, I'm going to have a changing slope, but I know it's always going to be in the negative direction because this is a negative slope. I'm going from a positive to a less positive all the way down to 0. So that's a negative slope. I also can see here that my slope is increasing here. So I'm going to have something that looks like I start here and I'm going to have something that is a line. So I'm going to have something that looks like that. So why did I make it positive? Why did I make it above 0 on the EMF axis? Because this is each one of these slopes. I start at 0 and then I get more and more negative. So I'm multiplying that negative by a negative. So that's why I made it positive. Why is it a line? It's a line because this looks parabolic and my slope changes, right? It's not like this one where, or this one where my slope is a constant. This is a changing slope. And I can see I go from 0, so there's my 0. I know it needs to be a positive number, and I know it gets bigger, so my slope is steeper here. So I'm going to have a positive number over here. So here my flux is 0 and it's not changing, so I have a 0 EMF. Here I've got a changing slope, so steep here and less steep and to 0 here. If pen will work. Okay, and so my slope here is a positive slope, so that means I'm going to have a negative. I'm going to start really steep. This is really steep slope, and I have to multiply it times a negative, so I'm going to start here, and then I go to 0. And then here, this is a constant flux, but it's not changing, so my EMF is going to be 0. Now let's just look and see. Here we go. So this is just a quick summary slide that we made, and we can see that this matches up. So negative, this should be positive, that's 0. This one's 0. This should be positive, this should be negative. That's right. This is positive, so this should be negative, 0, 0, and then positive, and that one looks right.